2, 3, go. I don't know if I did it. Okay, I think we're synced up. Wow, it's really loud right here. Let's turn it down a little bit. Okay, is that better? I think that's better. Alrighty, I got the headset down here so I can kind of concentrate for a little bit. Hey everybody, this is another math video. So, each of you who found the last couple of videos helpful, that's awesome. It was actually for a local school. It wasn't really for YouTube, but some of you actually found it helpful and even like did some of it, so that's good. Some of you just watched it. Guys, I mean, watching math is awesome, but you learn a lot from actually like writing it. So try to write it if you're gonna use these. It's good practice. Anywho, I have heard from some of you about certain types of math, and that is what we're gonna look at now. So I'm gonna do some practice problems here with you. This is gonna be on fractions and decimals, how to multiply them, how to do cross multiplying and simplification, things like that. So yeah, we're gonna hop right into it. I'm gonna pop this headset on, but don't mind it. I got an Xbox party in here, so I was about to say, like, I'm gonna actually talk in here while I'm doing this, but that would be massively distracting. So I'm actually just gonna take this off so that we can concentrate and like work with each other, okay? All right, so let's begin. This should be the part where I edit in like the thing like popping up. All right, so when it comes to multiplying fractions, okay, what we're gonna be looking at is okay, sorry, I got really distracted. All right, here we go. Let's get our pens out. Let's pick a color. All right, and then let's begin with our classic smiley face. Because if you don't start with a smiley face, you're a bobo. Simple. All right, so number one, okay, let's work an example one, okay? Let's take 1/3 and multiply it times 9/3. All right, first of all, this paper's a little bright for this ink, so let's go something a little darker. Yeah, there we go. That was a little bright, a little hard on the eyes. So what we're gonna be looking at is when we're multiplying fractions, we're gonna be looking at ways to simplify it in a diagonal. So either this way or this way. Here, let me circle it on here. So either this way or this way. And you'll see in a second what I mean by that, okay? So here, let's scooch this down just a little bit. And just follow these first couple examples before we start working them, okay? So, over here, I'm gonna look this way first, okay? Here, let me highlight it. I'm gonna look this way. There's nothing that I can actually simplify there. So when I say that, what I mean is there's nothing I can divide both of these numbers by. I could divide this by 1, I could divide this by 1, but I would get the same number. I could divide this by 3, but I couldn't divide this by 3. So there's nothing I can really divide both of those numbers by, okay? But if we look at it this way, there is a number we can divide both of these by. We can divide both of these numbers by 3. Okay? And if we do that, what we end up with is 1 down here and 3 up here. Okay? If that was a little too fast, just rewind it. I'm gonna actually undo this and show you one more time. When I look at this, there's one number that both of these can be divided by, and that's 3. So if I divide the bottom by 3, I'm going to get 1. If I divide this top by 3, I'm going to get 3. And when you're looking at cross multiplying, you want to do this in a diagonal, just like that. Okay? So fine, let's rewrite it over here. 1/1 times 3/3. Okay? And the reason I'm doing that is because we took this 9 divided by 3 and got 3. And we took this 3 divided by 3 and got 1. That's why, okay? 1 times 1, oh sorry, 1/1 times 3/3 equals, and now you just multiply it straight, 3/3. And 3 divided by 3 is 1, okay? Now I'll actually erase that last step, we'll look at it later. But that's how you do cross multiplication in a nutshell. We're gonna work several more of these, but that's how you do it, okay? Let's have a look at what would happen if we didn't cross multiply, right? So if we did 1/3 times 9/3, just straight up, like no cross multiplication, right? We would get 9/9, right? What's 9 divided by 9? 1, right? Look at your answer over here. Bro, look at this. Look at this. What's 3 divided by 3? 1. So as you can tell, you get the same answer no matter which way you go. And if some of you are saying, well then what's the point of cross multiplying if you're going to get the same answer? Look, there's a reason I don't teach math and I tutor it, okay? Because frankly, it doesn't matter if you cross multiply it or just straight up multiply it, because yes, you are going to get the same answer, okay? But for those of you who have a teacher who wants you to learn how to cross multiply, hey, just learn it. First of all, it ain't gonna hurt you to know it. And second of all, it does work out simpler because sometimes you're gonna get nasty big numbers. Here, let's work an example what happens if you just do it straight up versus actually learning how to cross multiply. Sometimes, even though you can get the same answer both ways, sometimes you get nasty big numbers that are just unnecessary. So let's take 4 over 27, right? Times 81 over 16. Now, you could just straight up multiply this, right? And you're gonna get 324 over some disgusting number, okay? You could, and if you simplified it, you would get the right answer, fine. But that's where simplification comes into play. That's where cross multiplying comes into play. Let's try it the cross multiply way, and then if you want, we'll go into a calculator and run it the dumb way. Or not the dumb way, but the complicated way. Alright? So I'm going to move this down here. We'll come back to this, okay? So let's remember we're looking in diagonals. And we're going to pick a darker green here, by the way. Just slightly darker, okay? Alright, so let's look at this first. So we're going to look at diagonals, okay? So what's a number that we can divide both of these by? Take a moment, pause the video if you want to try to figure it out on your own. Okay? Hopefully you've paused, because I'm about to give away the answer if you haven't. Now's your last chance. Okay. So, fine, you can divide both of these by 4. So you can divide 4 by 4, and you can divide 16 by 4, okay? And what that's going to give us is 4 down here. And when we divide 4 by 4, we get 1 up here, okay? Is there something we can divide? Now let's look at our next diagonal, right? Is there something we can divide both of these numbers by? Okay, take your time and pause it if you need to. Last warning, hopefully you've already paused and taken a look at it, because I might give away the answer. Okay, you can divide both of these by 9. You can also divide both of these by 27, but I won't do that to you, okay? You can divide both of these by 9. So if you divide 81 by 9, you get 9. And if you divide... Sorry, I'm having to swap colors. If you divide 27 by 9, you get 3, right? So now, let's just rewrite what we've got. We've got 1 over 3 times 9 over 4. And the reason, where I got that from is, we divided 4 by 4 and got 1. Here, let me circle it as we go. We divided 4 by 4 and got 1. And we divided 16 by 4 and got 4. Okay, remember that? Because we go in diagonals. Then we came over here and we divided 27 by 9 and got 3. And we divided 81 by 9 and got 9. Okay? That's how we ended up with 1 over 3 and 9 over 4. Okay? Now let's undo that because there's a lot of scribblies. Alright? So now let's just work on this part right here. Technically, you could cross multiply this too. Okay? So let's do that. Is there a number you can divide both of these by? And hopefully I hear you saying yes. These can both be divided by 3. Okay? So when you divide 9 by 3, you get 3. And when you divide 3 by 3, you get 1. Okay? And then there's nothing really for you to divide both 1 and 4 by, so we're going to leave those alone. Okay? So now our new fraction looks like this. 1 over 1 times 3 over 4. And I could have put a slash here just to make that a little simpler, right? Because that became 3. Now, you can get your final answer, which should be 3 over 4. Okay? Now, if any of that was too fast, you can just rewind it and take a look at it again. We're going to work several of these, so don't worry about it if you just want to move ahead. That's fine. We got plenty of these that we're going to work, okay? So now, let's actually put it into a calculator, because I promised you, and see if 3 over 4 comes out the same as whatever the frick this is. This ugly, disgusting number, okay? First of all, the number that goes on the bottom is 27 over 16. So, let's see what 27 times 16 is. Let me get my phone. Alright. Yeah? Alright.
I can't get that.
27 times 16.
No.
432. Okay? So 324. Hold on, I gotta get lighting right. Hello? Hello? Lighting? Thank you. Alright, so 324 over 432 is what goes down here, okay? Alright, let's just type in 324 divided by 432 and see what we get. 0.75. You see that, right? Let's type in 3 divided by 4 and see what we get. 3 divided by 4. 0.75. This is what I meant by you can multiply it the long way, but then you have to do disgusting big numbers like that, right? That's why we have simplification. So that you don't have to put in chunky monkey numbers. And yeah, okay? All right, very good. So let's go to number 3. Let's actually get a slightly darker blue. All right, number 3. And I'm making these up as we go. So I say number 3, but like I'm having to generate it in my head. 2/3 times 12 20ths. All right, and you take your time and pause this and see if you can work it out. So give it a minute. Hopefully you worked it out. I'm checking the party. Okay, they're okay. And when you get it worked through, unpause. Hopefully you worked it through, because I'm getting ready to work it. Hopefully you already paused it, okay? All right, so fine. Again, we're looking at just diagonals. So we're gonna look this way first. So what's a number that both of these can be divided by? Okay, and that should be 2. So you can divide both of these. Actually, the green worked better. You can divide both of these by 2. So we're going to divide the top by 2 and the bottom by 2. And that's going to give you 1 up top, and that's going to give you 10 on the bottom. Now we're going to look at the next diagonal, which is this. And when I say diagonal, I just mean like this way, okay? So what's a number that can be, what number can you divide both of these by, okay? Take your time. And the number you hopefully came up with was 3. You can divide the bottom by 3, you divide the top by 3. Notice that no matter what we're doing, there's 2 rules. We're always going in diagonals, and we have to divide both numbers by the same number, okay? So, 3 divided by 3 yields 1. And 12 divided by 3 yields 4. So, our answer, or not our answer, but our new problem should look like 1 over 1, because that's what's here, and times 4 over 10, which is right here. Got it? Now, let's come down here and multiply it all the way through. 1 times 4 is 4, and 1 times 10 is 10. 4 over 10 is our answer. Not simplified, but that's our starting answer, okay? 4 over 10 can be simplified, and what we mean by that is there's a number that you can divide both sides by. So you can divide the top by 2, and you can divide the bottom by 2. When you're simplifying fractions, that's different from multiplying it, okay? Multiplying it, you go in a diagonal. When you're simplifying, you want to go top to bottom, okay? So you pick a number that both the top and the bottom number can both be divided by. It's got to be the same number. So there will be no dividing the top by 2 and the bottom by 5. There will be none of that. Now, okay? There will be only the same number. So if you divide the top by 2, then you got to divide the bottom by 2. That's how you simplify. So 4 divided by 2 is 2, and 10 divided by 10 divided by 2 is 5. So your final answer, because it cannot be simplified anymore, is 2 over 5. And you, my friend, are a legend. All right, let's work a couple more here, and then we'll move on to decimals. So, number 4, let's take, actually, 2 over 5 and multiply it by 30 over 50. Okay? All right, take your time. You try to work this one. Go ahead and pause me. All right, hopefully you've already worked it out because I'm getting ready to show you the answer. So if not, go ahead and pause me. All right, here we go. So fine, we're working in diagonals as always when we're cross multiplying. So I'm looking at 2 and 50 and I'm saying, okay, these can both be divided by 2. So let's do that. It's going to turn into 1, and 50 divided by 2 is going to turn into 25. Looking at my next diagonal, and I'm looking at that and I'm saying, okay, these can both be divided by 5. So I'm going to divide this by 5. It's going to turn into 1. And I'm going to divide this by 5, and that's going to turn into 6. Okay? So let's look at what our new setup looks like. Should be 1 over 1 times 6 over 25. And our final answer will be 6 over 25. Piece of cake. And if it looks easy, it's because it is once you get the hang of it, okay? Math is mostly just practice. Like, math is half practice and half rules. Learn the rules, then practice. Learn the rules, then practice. Learn the rules, then practice. And then all of a sudden, people call you good at math. It's just knowing the rules and practicing, okay? Very good. Number 5. I actually have some practice problems on here from someone I helped recently, so I'm gonna actually pull those up. Hang on, because these would be really good. All right, yeah, here we go. All right, we're gonna do 7 over 15 times 15 over 32. Now, compared to what we've been doing, this is gonna be really easy, okay? Here, let's clean up this 15, it's a little sloppy. All right, so first of all, go ahead and pause if you haven't, because I'm about to give away the answer. All right, here we go. So look at your first diagonal, right? Is there a number that both of these can be divided by? And that's an absolute yes. You can divide them both by 15. This is the same number. It's so easy. Now, if you didn't do that and you did something like 5, that's fine too. It would still work out. But we're going to keep it simple. If I see the same number, then you can divide them by the same number. So let's do that. 15 divided by 15 yields 1. Okay? Let's look at this diagonal. Is there a number that you can divide 7 and 32 by? No. So that's going to stay the same. So fine, I'm not going to do anything with that. So my next problem looks like this. 7 over 1 times 1 over 32. And your final answer? 7 over 32. Ta-da! Piece of cake. Okay, let's have a look at another one that may be a little less straightforward. And if any of this, if you want to review any of this, just rewind the video and try to work it before I do. Let's have a look at what happens when you take a mixed number, okay? So let's take 2 2/3 and multiply it by, say, 9/4, okay? First of all, this is the same thing, guys. This is the same thing. But what you want to do is take the mixed number and turn it into a fraction you can actually work with. So let's try that. The very first step is to turn this mixed number into an actual fraction. So you multiply the bottom and add the bottom to the top. So what that looks like is 2 times 3 is 6. And 6 plus, here, let me circle it as I go. 2 times 3 is 6. And then 6 plus 2 is 8. So your new number should be 8. And then you keep the denominator the same. And you probably know this already, but we're just being thorough. All right, and then you just go ahead and bring this down like normal. So that's going to be 9 over 4. Okay, piece of cake, not bad. Once it's in this form, you know exactly what to do with it. Just multiply it like normal. So we're going to look at diagonals. Here's your first diagonal. Is there a number both of these can be divided by? And the answer is a big fat yes. You can divide them both by 4. So that's going to give you 2 up here. And 4 divided by 4 is 1. Okay. And is there a number you can divide, or let's take our next diagonal. Is there a number you can divide both of these by? And the answer is a big fat yes. You can divide the bottom by 3 and the top by 3. And so that's going to give you 1 at the bottom and 3 at the top. So let's rewrite our problem, and I want you guys to really, just rewrite your problem. Don't try to do a whole bunch of stuff in your head. Listen, I can go ahead and tell you, as someone who's been through Calculus 2, I am really good at math, okay? I'm only good at math because I practice and I know the rules. So don't get it twisted. It's not like you come out born like, wah, good at math. No. Practice and knowing the rules. But let me go ahead and tell you something, because I used to think this too. There's nothing impressive about being able to do math in your head. It's just not. Who cares? Okay? Write it on the paper. Nobody cares if you can do it in your head. Nobody. The only thing that matters is, can you get it correct? Do you know the rules, and can you work the problem? That is what's impressive. And by the way, it's not impressive if you're just getting them right the first go. That's not impressive either. What's impressive is you putting in the practice and the time. Because anybody who puts in the practice and time will get them right. Whether it takes you a day or 12 days, matters not. Do you know the rules, and do you know how to work them? Because if you know the rules and you practice, you will know how to work them. And I do not care if it takes you a day or 12 days. Period. So take your time and enjoy it. But anywho, please write your steps out, okay? It took me until pre-calculus to learn that, because I too was trying to be the cool kid and was like, I can do this in my head. But as I was trying to be impressive, I was getting C's and, well, not very many C's, but a couple of C's and lots of B's because I wasn't writing out my steps. And the minute I started writing out my steps, all those went to A's. Period. So it is all fine to write your stuff out. In fact, it makes you more accurate. And ironically, the more you write it out, the less you need to write it out, and then you start doing it in your head. So by writing it out, you gain the ability to do it in your head. I still don't use the ability because it's better to write it out. Anyway, okay, fine. So rewrite your problem, okay? So 2 times 3 equals 6. On the bottom, you got 1. So your answer is 6 over 1. However, we know what 6 over 1 is. 6 over 1 literally means 6 divided by 1, which is 6. Okay? All right. Now, if you forgot if you needed to review how to convert that mixed fraction, go ahead and take another look at that. Or just rewind the video, because I'm going to write some practice problems down here for you. And we're going to move on to decimals, okay? So you can work these practice problems on your own. 1 over 1/4 times 3 over 1/3. And number 8, we'll do, hang on, I'm looking at this worksheet. 8 over 9 times 6 over 7. Oh, I hear laughter, hang on. Okay, I think they're okay. Okay, yeah, I don't know whether, okay, they're fine. All right, and one more practice problem. 5 over 6 times 2 over 3. All right, take your time, go ahead and pause the video and try to work these through. So pause me now, because I'm going to blaze through it so we can move on to decimals. Because I'm looking at the time, we've been talking for 23 minutes, this is a long time for video. Okay, got it? All right, here we go. All right, so for this, hopefully you multiplied and got your mixed fraction converted, so it should be 5 over 4 times, multiply, add to the top, so you get 10 over 3. And then hopefully for your next step, you went ahead and looked at your diagonals and decided that this could be divided by 2, this could be divided, hold up, those colors are boo-boo. Both of these are going to be divided by 2, and after you did that, you discovered that the bottom was 2 and that the top was 5. Then you rewrote your problem because you're cool, which means you write out all your stuff. So 5 over 2 times 5 over 3. And then you multiplied it like normal and got your answer of 25 over 6, which could not be simplified anymore. 2, 3. Okay? All right, yeah, that video ran really long, so let's get this wrapped up, okay? So your final answer in the last one was 25 over 6. All right, here's the rest of your answers. 9 over 6. Or sorry, we're going to take 9 and 6, find a number that's in common with them, which you found was 3, okay? After you divided 9 by 3, you got 3 at the bottom, and you got 2 at the top. You then took a look at 8 and 7 and decided, oh my God, there's nothing I can divide both of those by, and you left it alone, okay? Then you multiplied like normal and brought your stuff out, because you're cool, and you did 8 over 3 times 2 over 7, which gave you your final answer of 16 over 21, which will not be simplified anymore, and you are done. Your next one, you looked at your diagonal and decided, oh my God, I can divide both of these by 2. So you divided the top by 2 and the bottom by 2, which gave you 3 on the bottom and 1 on the top. You then proceeded to take your answer, or sorry, your problem, which is a little bit sloppy here, 5 over 3, and multiplied it by 1 over 3. And then you multiply like normal, which is 5 over 9, which will not be simplified anymore, and you are D-O-N-E. My friend, if you worked through those problems and understood it, you are plenty ready for anything involving cross-multiplying fractions. Really good for you. Let's take a quick look at decimals. Quick look, because it won't take long. I'm looking at the timer right now. It's 2 minutes, so this has been a 25-minute video so far. So no more than 30 on this. Actually, why don't we split these up into 2 videos? Yeah, we're gonna split these up. Okay, really good job. Hopefully you got it, and I'll see you on part 2 for multiplying decimals.